Hello and welcome back to Introduction to Physics. My name is Paul Eric and I teach physics, astronomy, and geology at Ozarks Technical Community College in Springfield, Missouri. Today we want to review for the lecture Unit 4 exam. And so these are going to be the lessons that you need to review. So lesson number 6 on energy, lesson number 7 on rotational motion, lesson number 8 on gravity, and lesson 24 on nuclear physics. So let's begin by talking about energy. So in your textbook, you ought to be reading chapter 7, sections 1 through 6, and then from chapter 18, sections 3 and 6. So let's begin by, you should know what energy is. So what's the definition of any kind of energy? You should also notice that its abbreviation is the letter E, and then the official metric unit for it is the joule. You should also be able to tell me about 4 different kinds of energy. And so in this picture here, you can see chemical energy, electrical energy, light energy, thermal energy, mechanical energy, and then nuclear energy. So be able to give me 4 of those different kinds of energy on the exam. Okay, then we concentrated though on mechanical energy, and there were 2 kinds of mechanical energy. So you're going to have potential energy and then kinetic energy. So potential energy, and we're going to abbreviate that by E sub P, is going to be energy of position. So that depending on where it's located at, it's going to have differing amounts of potential energy. Now the only kind of potential energy that you're going to need to know for the exam is the gravitational potential energy. And so that is going to be given by M and then G and then H, where M is going to be the mass of the object that you're going to lift a certain height above the ground. So H is for height, M is for the mass of the object, and then G is the acceleration due to gravity. So G is going to be equal to 9.8 meters per second squared. So it's an acceleration, but it also represents the magnitude of Earth's gravitational field when you're close to the Earth's surface. So this is a constant that goes into this formula. So remember, this is not milligrams. So this is mass in kilograms, and then this is G, and you have to plug in this number for it. So you should be able to solve a question like this, a conceptual question, or you should be able to solve a mathematical question using this formula. Okay, then we talked about kinetic energy. So the second kind of mechanical energy is called kinetic energy, and so that is going to be E sub K, and then its formula is going to be 1/2 mv squared. So kinetic energy is energy of motion. So if something is moving, it has a certain velocity v, which means it has kinetic energy. So notice it also depends on mass, just like this one up here did, but it depends on how fast it's moving. So if it's not moving, v is equal to 0, and it has no kinetic energy. Now, objects have both kinds of energy. So the total mechanical energy is going to be equal to the sum of its potential energy plus its kinetic energy. And so here's an example of a conceptual question where if the speed of something gets 5 times greater, what happens to its kinetic energy. So do not say that the energy increases by a factor of 5 because you forgot to square it. So it's 5 times 5 or 25 times the kinetic energy. And then you should also be able to do a mathematical question by plugging in numbers into this formula. All right, let's take a break. When we come back, we will continue with our review for the Unit 4 lecture exam.